And that's all typically shown in charts and other areas. You can go find that kind of information. The approach valve is the speed in which the frame descends. And the frame descends, there is no given rate when it's free falling before it hits the material. However, when it does hit the material, or the blade starts to enter the material, this valve becomes dead or not used, because what it's doing is the blade is forced up inside of the guides, and the cutting force at that point takes over. And the cutting force, like I said, is the amount of pressure that the blade's pushing through. As the cutting force reaches the setting on the gauge, the frame will shut off until the material is eroded away by the blade. The blade will come out of the guides. At that point, the frame will start lowering again. It's a pretty simple system. It's all in series. The oil coming out of the cylinders goes through the metering valves. The metering valves are plumbed in series, comes up through the approach valve, and then back to tank. And that's the flow of the oil coming through the hydraulic lines. The cutting force is actually is a reference on to where the amount of pressure is put on the top of the metering valves. And I'm going to show you the metering valves. The metering valves are right here. There's two of them. There's one on each guide. Typically on our Series 2 machines, they'll have one on each guide. Again, they're plumbed in series. But the top fitting, the 1/4 inch line, is the cutting force. So on the gauge I just showed a second ago, in the pressure regulator, applies the amount of pressure shown on the gauge to the top of this spool. There's a spool inside. The spool actuates up and down as the blade comes up and down in the guide, shutting the flow oil off that goes back through the tank, stopping the frame from coming through the cut. And this is constantly working. It's constantly, the blade's constantly moving up and down through the cut, and this is how we get our optimal cutting system that we use on our machines. I'm going to show quickly how we first set these up to make sure that our system is working properly. It's kind of a rudimentary, but it works really good. To see that the metering valve system is working properly, I'm going to turn the hydraulic system on, so it's going to be a little noisy. Lowering the frame without the blade running. And you'll see as the blade moves up, I can hold this. The weight of the frame is being held by this 2x4. It shuts off, it's not drifting down. If it wasn't working properly, it'd start drifting down. And that's it. Now as the material would be cutting through, the blade would be cutting through the material, drops out, the frame starts lowering again. Now, as you increase the pressure on the pressure gauge, I have it set about 50. If I increase the pressure to 150, now it's going to get really heavy. It's going to have a real heavy feeling to it. So each time I do this, it starts to put more pressure on it. It will shut off. It will stop moving down. It just gets heavier and heavier. That's how we initially start with our metering valves to see that they're working properly. And that tells me that the flow oil is being shut off, and it's going to stop the frame from trying to plow through the material with the blade. being said, that's how we first start off, is the frame has to fall at a certain rate. We don't have a defined rate, but that's a decent rate. Now your approach valve is open. I mean, you can open it 5 turns, whatever, wide open. That's as fast as that frame can come down. The approach valve controls that, and that's the little star handle valve. The approach valve is that valve right there. That controls the speed of the frame coming down. I'll demonstrate. You can control that faster or slower. You can also use that to cut with. If you want a really slow feed rate, a really high cutting force, then you can control your feed throughout the cut consistently with just the valve. You can increase it. And it's also working in conjunction with the metering system. So if one isn't working, the other's going to take over. So what we're trying to achieve is the maximum feed rate with the least amount of movement in the blade to stop the metering valve flow to shut the blade off. So we want the minimal